Okay, so this unit is called statistics, and we're going to be working with some different kind of organizations of statistics that we can be looking at. The first is called a box plot, and also sometimes called a box and whisker chart. But essentially, it is made up of two boxes and then these little lines at the end of them. You don't need to have this copied down, but just kind of want to show you those different regions. So a box plot is made of those two boxes plus the little line in the end. Those are called the whiskers for the box and whisker. This shows you some different information. One of them is the minimum, and that is essentially the lowest number in your data. So it's going to be the furthest to the left, or later we'll see one that is kind of the lowest one. There is something called the lower quartile. The lower quartile. And that is right here. It's kind of the furthest left edge of the box. And that is essentially the lowest 25% of your data. Then there is the median, which is this line in the middle. This is the median. And that is, as the name implies, it's the middle of your data, so the middle number of your data. There's the upper quartile, which is the other edge of this box, kind of the furthest to the right edge of the box. That would show you where the top 25% of your data begins. Finally, we have the maximum. That would be the end of this little whisker, the end of the line at the edge of the box. The maximum would be the biggest number or the highest number. And also will show you any outliers. Outliers. Now, outliers are numbers that are basically so high or so low that they don't really belong with your data. So that'd be something like if there was a dot over here, way to the right, that would be an outlier. It's so high or so far to the right that it doesn't even really belong with the rest of the data. Or same thing if we put a dot over here. This could be an outlier over here. If we had a dot or a number so low that it doesn't really belong with the rest of them. So like I said, the minimum is the smallest number in a set of numbers. So when you have a bunch of numbers, the minimum would be the smallest number. The median is the middle number. So if you look at all your numbers, whichever one is in the middle, that would be the median. And the maximum is the largest number, or the biggest number. So you have your minimum, your median, and your maximum are the smallest, middle, and largest numbers. Now, outliers are numbers that are significantly smaller or larger than the other numbers in your set of data. So if they are significantly smaller or larger than the rest of your numbers, then they are called outliers. Basically, like I said before, it just means a number that's either so big or so small that it doesn't belong with the rest of the numbers. That is what an outlier is. And then for the upper quartile and the lower quartile, when you put a set of numbers in order from smallest to largest, first we would divide the list in half and find the middle of the lower set. So you're going to divide your list into two halves and then find the middle of the lowest half. That is the lower quartile. And we'll look at what that means in a minute. And then the middle of the upper set would be called the upper quartile. The upper quartile. So what that looks like is if we have these numbers, this set of numbers here, the 2 through 11 that we're going to be looking at, what the first we would do is we would divide the middle, or find the middle, which is the median. So here I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. We need to find the middle of these numbers. And so in the middle is going to be kind of in between the 5th and the 6th one. It'd be right about there. Where we have 5 numbers on the left and we have 5 numbers on the right. So the median would be in there. When you don't have an exact number that's right in the middle, like we don't have a single number that's in the middle, you need to find the average of these two, which means you add them together and divide by 2. So we take the 6 and the 8, add them together, that would be 14, divide by 2, and the median will be 7. So 7 is the median, means it's the number that's in the middle of our numbers, the middle of our data. Okay. Now, to find the lower quartile, we need to find the middle of the bottom half of our data. So we're looking at just this half of the numbers, and we need to find the middle. So here, that number would be 3, because 3 is in the middle of this bottom half. And so the lower quartile would be 3. And then we'll do the same for the upper half, find the number that's in the middle of these, and that number would be 9, so the upper quartile is 9. Okay. Then we need to find our minimum and maximum. So it says use the smallest number and the largest number. These are the minimum and the maximum. So our smallest number would be 2, which is the minimum. Our largest number is 11, so that would be the maximum. And then we're going to draw this box plot on a number line. So starting with our minimum at 2, I'd put a line here at 2. And I'll put a maximum here at 11. We'll have a line there. If you look at the box plots, you have this line that's from your minimum and then a kind of horizontal line until you get to the lower quartile. So our lower quartile, we said, is at 3. So I'm going to draw a line from 2 to 3, and I know that's where my lower quartile is going to be. Okay. Then our median, we said, was at 7. That would be here. In between our lower quartile and our median, we should have this box shape. So we're going to have a box from the lower quartile at 3 to the median at 7. So this represents our lower quartile. Then we need to draw the line from our maximum to our upper quartile. So our maximum was at 11. Our upper quartile was at 9, so I'll have a line until that 9, and then from the upper quartile to the median, I would have the box. Okay. So this is, poorly drawn. The lines are not very straight, but this is what your box plot should look like. Where here we have our minimum. This would be our lower quartile. This line in the middle would be the median. This line at the edge of the box would be the upper quartile. And finally, this line at the end would be the maximum. Okay. So that is what a box plot looks like. What we're going to be doing next is looking at some things that we can use or learn from a box plot that we are given. So here we have an example of some visitors at aquarium events, and there's a live show and a movie. So this says you can compare side-by-side box plots based on the median. Based on the median is where we're going to be looking at these. Based on the median, we're comparing the median for the movie compared to the live show. So if I find the median at here for the movie, that looks like it would be at 85 for the live show, or for the movie, I mean. Then for the live show, our median, this line that's in the middle of our box, is at 80. And so it looks like we have a larger median for the movie than for the live show. For the movie, it's at 85, and for the live show, it's only at 80. So the live show, or the movie, has a higher or a larger median. We can also compare them based off of the range. The range is the highest number minus the lowest number. That's what this says over here on the side. The range is the highest number minus the lowest number. So for the live show, the highest number or the maximum was 100. The minimum or the lowest number was 60. So in order to find the range of that live show, we would take 100 minus 60, and that gives us a range of 40. The live show has a range of 40. And then we can do the same thing for the movie. The maximum for the movie was again 100. The minimum for the movie looks like it's at 55. So for the range of the movie, this would be 100 minus 55, which would give us a range of 45. And so since the movie has a range of 45, the range of the movie is larger. There's a bigger range. And that also means that there is greater variation. If there's a bigger range, that means there's a bigger variation, kind of a bigger, different number of things that it could be. One other way we can compare the box plots is based on what's called skewness. And skewness is basically how much are things shifted to one side or to the other. So if we look at the median line in the box plot for the live shows, it's closer to the lower quartile. All right, if we look at this line for the median, it's closer to the lower quartile than it is to the upper quartile. If that's the case, it is called right skewed, kind of like this one down here, right skewed. It's kind of the opposite of what you would think, but because the median is closer to the lower quartile, we say that it is right skewed. Then for the median of the movie, we can see that that is closer to the upper quartile. It's closer to the upper quartile, so that makes it left skewed. So if you see down here where it says left skew, the median is closer to the upper quartile, so that makes it a left skew. Again, it's kind of opposite of what you think, but the one that if it's closer to the upper quartile, that makes it a left skew. If it's closer to the lower quartile, it is a right skew. If the median is basically right in the middle, kind of like this one down here, is right in the middle of the upper and the lower quartile, then we'd say there is no skew, if it's kind of right in the middle. Okay, one way that we can compare if one set of things is better than another is using the median. If you look at the median of the movie compared to the median of the live show, we said the median of the movie was, let's see, the median of the movie was 85, and the median of the live show was only 80, and so we would say that the movie did better than the live show because the median was higher. If you look at these boxes, this median line for the movie is higher than the median line for the live show. And so we would say that the movie did better because it has a higher median. Okay. Then we need to check to see if there are outliers. We can see if a box plot has any outliers based on whether you see dots on the outside. So again, outliers are numbers that are so big or so high that they don't really belong with the data. If you look at these box plots, we don't have any dots that are way too high or way too low like these would be. And so these ones do not have outliers. This data set does not have any outliers. Because if there were outliers, then you would have dots, kind of like we have down here. These dots that are too high for the box plots are the outliers. We can also see box plots that are vertical. So instead of kind of horizontal the ways that these ones are, we can see them as vertical, like this one. And the same thing will apply as the others, where these dots would be outliers. The line in the middle would still be the median. And then here we would have, this line would be the upper quartile. This line down here would be the lower quartile. Down here, this bottom line would be the minimum. And this line up at the top would be the maximum. So we have all the same information, it's just kind of showing in a different different way. So let's compare these vertical box plots to each other. We have two vertical box plots. The first thing it asks us to do is to compare the medians. So if I see the median for school 1 would be this green line, and it's at 85. And then if I look at the median, again, that's green line for school 2, it looks like it's at 70. And so we would say that school 1 has a higher median than school 2. Because this green line is at 85 for school 1, and it's at 70 for school 2. When it asks us to compare the ranges is the maximum minus the minimum. So for school 1, the maximum is at 95, and the minimum is at 65. So for the range of school 1, we would take 95 minus 65, and that gives us a range of 30. Okay. For the range of school 2, it looks like the maximum is at 80, and the minimum is at 55. And so for the range of school 2, the maximum is at 80, the minimum is at 55, and so we would subtract that and get 25 for the range of school 2. And so if the range of school 1 is 30, the range of school 2 is 25, then we would say that school 1 has a higher range than school 2 because its range is bigger. It's a bigger number. Okay. Finally, what we're going to be looking at is the skewness of these two box plots. And so if I look at school 1, I can see that this median is close to the upper quartile. So if I look back up to where we talked about the skewness, if the median is close to the upper quartile, we'd say this is a left skew. So this would be a left skew for school 1. School 1 has a left skew. But if I look at school 2, it is pretty much in the middle of the upper quartile and the lower quartile. It's pretty much in the middle. And so school 2 has no skew. It's not to one side or the other. Okay. So we would say it has no skew. Okay. So this page is for practice. For you to do on your own. If you have any questions, let me know, and I'll be happy to answer those questions. But this page and the following page are for you to do on your own. And when you are finished with that, then you can move on to the next section.